Hi everyone. This week we're going to cover chapter 15, and as you can see from the PowerPoint, it says thinking about inference. And I told you in the assignment to look at this chapter, and it might be a good idea to look at the PowerPoint slides. So I'm going to go over them with you. And the whole reason that we're doing chapter 15 is for you to be able to be good research readers. Now you're going to be doing some research reading right now as you prepare your own article. And you should have done this when you were looking at the article research assignment that you completed a few weeks ago. So the whole idea is, how do you know this research that you're reading is good or not? And let me give you some examples of stuff that you might have believed was true. Now, if you're of a certain age, you probably remember that you could buy soda in schools, and then they took the soda out and replaced it with water. But we find that the students are not losing any weight because of soda. It's not making a difference. Even though 40 states have removed soda from cafeterias, some of them, the students are drinking sweet juices and sugar-filled juices, so they're getting their sugar in that way. So no change has been happening. So this is a fallacy that we've all thought was true, that by changing the diet of the students it would help. Another one, that there's widespread sexual harassment in students from grades 7 to 12, so from middle school to high school. This may not have been a surprise for you, but now they have some research that shows 87% of those who have been harassed reported negative effects, and you can see some of the numbers here. So these are available on NewYorkTimes.com. And so just giving you some, there's some graphics over here that I've used as well. So the other thing that is probably a myth and has been debunked is that freshmen in high school will gain 15 pounds. And actually most freshmen will gain an average of 2.5 to 3.5 pounds. So the whole idea is, like, when you read these numbers, how do you know they're true? So that's what this chapter is all about. Now there's some Z procedures, and that's one of the first things they talk about. So let me go through this slowly with you. If you know the standard deviation here of the population, that's the whole population. Let's say you're talking about all freshmen in college, the whole population of freshmen in college. Again, the confidence interval would be this. The mu is this. Confidence interval is going to be a key phrase here. To test a null hypothesis, that means that there's no difference, we use one sample statistical, the statistical norm procedure. These are called Z procedures because they both involve one sample. Okay, you take a sample of the population, you do a test on it. What the heck does this mean? Well, when you read an article, you have to know what the confidence level is. So this is what we were talking about in chapter 14. The data must be an SRS standard. It must be a simple random sample, and you have to know where the data come from. Okay, so you have to be sure that you know the different methods. It's important to read the methodologies. If you're doing a thing on a population of freshmen in college and you're going to the mall to ask people questions, obviously your data is not, first of all, random, and second, it's not even part of the sample, part of the population. So outliers can distort the result. Maybe you know that. And the shape of the population distribution matters. If it's skewed, it has to be a nice bell curve. You should know that. And the population standard deviation must be known. They talk about in chapter 17, but for now we don't worry about this. So if you don't know the standard population, remember the thing we did with students' height? Okay, that one you would know, and then you could do your own little research as well. So where did the data come from? And so when you use statistical inference, remember, you're making an inference from your sample. You are acting as if your data, our probability sample, will come from a randomized experiment. So it has to be random. Some of you talked about doing a research project based on in some polls or whatever. It would have to be sampled for it to be a correct statistical project. And the confidence intervals and tests cannot remedy the flaws. Okay, so that has to be true as well. So be sure about that. Here's an example. So mammary artery ligation. So surgeons tested a procedure to alleviate pain caused by inadequate blood supply to the heart, and the patients reported statistically significant reduction. That means it counts. Significant reduction. So what it says here, when you read an article like this, it indicates that something other than chance is at work. It wasn't just an opportunity or something by odds that it worked, but it does not say what that something is. Okay, it was not controlled. They didn't have a group they're doing the pain in one way, and then the placebo effect in the other way. So it's not a control experiment. So therefore, they stopped, and surgeons immediately stopped performing when they saw that the control experiment showed that there was some reduction in pain. So a lot of times in medical situations, they'll stop, and then they'll give the benefit to everyone. They'll stop forcing the placebo. So now this is what the confidence intervals are. Okay, the margin of error. So that tells you the margin of error. Now you know the margin of error will get smaller when you get more people. That's your n right here. Your n right there. And then the confidence level will get smaller as well. And then when your deviation gets smaller, there's less variation. Okay, so you know this stuff. This is the education performance test, and 95% confidence intervals. They tell you the rating over here, and the 90% interval. Okay, what the heck does this mean? Means that the confidence intervals will determine your margin of error. So the margin of error in a confidence interval covers only random sampling errors. Okay, practical difficulties such as undercoverage and non-response are often more serious. This happens sometimes with the Census Bureau, that they don't count everybody. They don't count, in the old days, they didn't count people who were of a different color than white, or poverty, or people who are homeless. It's very difficult to count these people. So these are undercoverage or underreported. So the margin of error does not take these difficulties into account. So be aware of this when you're reading any study results. Now, in your study results, you might have seen the p-value. Okay, so that p-value, what the heck does this mean? Well, let's look at a null hypothesis, meaning that there's no change. This represents an assumption that people have believed in for years, just like that every freshman gains 15 pounds. Okay, that would be an assumption. Where was the data that made this? People just did it because they thought it was true. So strong evidence will be needed to persuade them otherwise, and that's why an article like this is based on the research, and you can find the research here. Okay, so they interviewed 7,418 people from 17 to 20. That's a pretty big range, a number of people. That's a big N. Now, if the consequences of rejecting HR are great, such as making an expensive, difficult change from one procedure to another, then strong evidence as to the benefits of the change will be required. Okay, so that means that, let's say there's another fallacy that taking the DPT shots, or the early childhood shots, will cause autism, and there's absolutely no evidence to prove that, but still people believe in it and are not having their students immunized. So there has to be a lot of change for this to occur. Okay, so there's a cutoff value of 0.05. That's a 95%. In other words, when you have an alpha of 0.05, that means you're 95% sure that you have a significant data. Okay, that your statistics really mean something. So for one-sided tests, okay, this means that you're only saying one is greater than the other. In other words, there is a change, and for most of you should be looking at null hypothesis, that there is no change. And I'll give you an example in a couple of seconds here. Okay, so the evidence against HO is stronger when the alternative is one-sided. Okay, use one-sided tests if you know the direction of possible deviation. So if I say that if I do these online YouTube videos, then your grades will go up. That's one side significantly. So I have to give a certain number. So let's say before I used YouTube, the average grade of the class was 85, and now the average grade is 86. Is that significant? Well, probably not for a classroom because there are not a big number of students. But if I did it over a long period of time, maybe. But that's a one-sided thing. If I said my hypothesis was that there is no difference between using YouTube videos and not using YouTube videos, and that would be both sides. It doesn't matter if it's good or bad. But if it goes into that realm of significance, then I can say, yes, it is significant. I'm just not giving a direction. So the cautions here, you want to make sure that you have the cautions that when a sample size is very large, tiny deviations will be statistically significant. When it's very small, large deviations from the null might go undetected, so you have to watch out. So statistical significance is not the same as practical significance. Remember that. There's a statistical significance, you'll hear that term. So it's not meaning the practical significance. So here's a good example that I told you about. Alcohol use. Okay? So here's the alternative hypothesis. The percentage of high school students who used alcohol in 1993 is less than those who used it in 1992. The null hypothesis, where it's both sides, there is no difference in the percentage of high school students who use in 93 and 92. So that's how the null hypothesis is worded. You may want to use that in your research article. Use a null hypothesis. That way you don't have to go in one direction or the other. So this is the data they collected, and it's that 8th, 10th, and 12th grade, and this is the use, and they asked 17,000 seniors, and you can see all the numbers here. So there's a lot of, this is a big N, okay? How they did it, I'm not sure, because not everyone tells the truth on these types of surveys. That's another thing you have to be. Now here's the p-value here, 0.001. That is very small. 0.04, not very small at all. That's kind of big. So 0.001, that looks like it's significantly is significant. It's statistically significant. So what the article suggests that the survey reveals good news since the differences are all negative. Okay, the differences are down, but are they significant? Did it really make a difference? They are down, that's good, but are they significant? So the differences are all statistically significant. All p-values are less than 0.05. That's a 95%. Even the 0.04, which is not that great, not as good as this. This went down by a great big number, but the 0.04. Now, how did they get that number? They figured this p-value here. They get it by going all the way back to this slide. You won't have to do this. I just want you to be able to read this, okay, to understand about this. So let's go back to this, and the differences. Let's see, the 10th and 12th grade are not practically significant because each is less than 1%. Okay. So these are not practically. This is pretty good. Okay, so you can say that it's practical significance and a statistical significance in the 8th grade drop in drinking. 10th and 12th grade, sorry, no. And then one more thing, and one more is when you have memory loss in American hearing, American deaf, and Chinese adults. So it is the title of the article, Aging Free from Negative Stereotypes, Successful Memory in China and Among the American Deaf. I'm sure you wouldn't look this up on your own, but it's an example here. So the average memory test scores, the higher is better. Of course, you can remember things more. 30 subjects with 30. There's the key right there. 30 subjects were sampled. So right away, red flag, 30 samples, okay? So you can see that here are the average memory test scores and so on, okay? So young Americans, hearing and deaf, there they are, have significantly higher mean scores. Okay, so this is what Science News said at the time. Memory scores for older and younger Chinese did not statistically differ. Okay, and that's what they're saying here compared to the young, and that's not the right, because since the sample sizes are very small, there's an increased chance that the test will result in no statistically significant difference. Okay, you won't detect it because you only have 30 people. The surprising result, surprisingly, right there. The surprising result could just be because the sample size was too small to detect a difference. Okay? A larger sample may yield different results. The last slide you should look at, there are many more, I'm only looking up to here, is that the multiple analysis. So suppose that 20 null hypotheses are true. 20 null hypotheses. Okay, suppose that you have 20 null hypotheses. So each test has a 5% chance of being significant at the 5% level. Okay, 95%. That's 95%. I mean, it's 95% sure that it is significant. That's what it means. So if the alpha is 0.05, the results, the extreme, occur only 5% of the time just by chance when the null hypothesis is true. That's what I just said. Okay, it means it only happens 5% of the time. The other 95% is that it means something. Thus, we expect about 1 in 20 tests, which is 5%, to give a significant result just by chance. So let's go back to your survey of freshmen, maybe their height, and you did 20 times you did this test. Okay, you interviewed or you talked to 100 students 20 times. Okay, so here's the last bullet item. Running one test and reaching the alpha of 0.05 level is reasonably good evidence against the null hypothesis. However, if you did it 20 times and reaching that level only once, it's not. Okay, so let's say you interviewed 100 people to find their height or whatever you're testing, and you found that the test reached the level of 0.05, the 95% confidence level. That's pretty good evidence against your null hypothesis, meaning that there was no difference. Okay, for instance, there's no difference in the people I survey from the average height. Okay, that could be a null hypothesis, no difference. However, if I run it 20 times, I do 20 sets of 100 people, and I reached that level only once, that's not very good. Okay, so you have to watch out about these multiple analyses here. So probability at all 20, and so that's what they're saying right here. So that's what I want you to be able to do, is that when you read, now these are articles in newspapers and not research articles. They're based on research, you can see right here. So what these people at the New York Times do is they look up research and they find the research and they just report it. Now what you have to do in your research article is to think of a hypothesis and look up the research. It may mean finding data. I've had some good ideas. I've had some ideas that are really require a lot of work. So you just have to be careful. So this chapter 15 can be very confusing. Again, I hope that you looked at this and this video up to these PowerPoint slides. And if you have any questions, let me know.